Two and a Half Admins, episode 154. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Before we get started, your customary Clara plug, Alan, is Clara 2023 recommended summer reads, FreeBSD and Linux.
So for the summer, we collected an article series we've been building for the last year that talks about some of the advantages and disadvantages comparing FreeBSD and Linux, but also how to be good at both. So provide some like Rosetta Stones on, if you know how to do a certain operation on one of the operating systems, it can convert it to the other and allow you to easily switch back and forth between BSD and Linux and get good at both.
Right, well, link in the show notes as usual. Let's do some news then. And the first one is that from February next year, AWS is going to charge customers for public IPv4 addresses. But don't worry, it's only half a cent an hour. That's not going to add up.
I mean, it's about $3 a month per IP address. Honestly, this was kind of a meh story for me. Plenty of hosting providers have been charging for IP addresses for a very long time. AWS isn't exactly blazing a new trail here. They're more joining the pack.
Yeah, even some of the places that were less anal about it before have all ramped it up. I don't think anywhere in Europe that I rent machines charges me less than like €1.50 a month for each IP address.
I love the idea of just saying the heck with it and making IPv6 only sites. It sounds appealing, but the fact of the matter is there's just, I don't know when we're going to get away from the problem of having literally millions of people not actually able to successfully resolve IPv6 stuff, from their home internet, or in many cases, their small business internet. But it is still a very widespread issue. And if I set up a site with nothing but IPv6 connectivity tomorrow, I will set up a site that will immediately have huge numbers of problem reports as people say they can't get to it.
I'm guessing the main thing this will do is force people that have instances that don't need to have public IP addresses to stop using them. Especially if you have a bunch of infrastructure where there's only going to be one thing actually facing the internet, one machine, or even just not CloudFront. What do they call their load balancer? Route 53? That's the DNS part. What's the actual load balancer?
I forget what they call it.
Yeah, but a load balancer be the one thing with the public IP facing out on the internet, and then it can handle the v6 internally to everything on the inside of the network there and save you a bunch of money on IPs that you don't need. But like Jim said, everybody's still going to need one IPv4 address to route everything through. It's just that charging this half a cent an hour, or even if it's just a couple bucks a month, usually provides just that enough incentive for people to decide, okay, these three machines don't need a public IP anymore.
Yeah, even without a load balancer, if you're talking about a fairly substantial site or project that's got like a full-on stack where you've got multiple machines or VMs serving separate roles, and not all of them are public facing. Like, if you might have multiple application servers that are public facing, but, two internal DB servers and, an internal static server, a couple other things going on that the public is not supposed to touch. And if the public's not supposed to touch them, there's no reason whatsoever those machines shouldn't be talking to each other with IPv6 or with private IPv4, whichever. It really boils down to pare your public IPv4 usage down to the minimum.
Yep.
Which is a good idea, and it was a good idea a decade ago. It's a shame that it's still not a whole lot more than a good idea yet.
Yeah, I remember back in the 90s when the power plant I worked at had a giant allocation, like a /20 or something. And so they used routable IP addresses for their entire internal network. They weren't routable to the internet. Like you couldn't actually reach them from the internet. It was all firewalled off. But they used actual useful real IPv4 allocations for every Windows machine in the entire plant for absolutely no reason.
I headed an IT Tiger team once that went into a fairly large organization. I'm going to be real cagey because I don't want to name and shame anybody, almost 20 years later. But I was hired to lead this team into an organization and deal with some pretty serious InfoSec issues that they had going on. And their entire Windows domain, everything, every single desktop machine, every internal only server, you name it, they all had public IP addresses and all were publicly reachable. Nothing was firewalled off from the internet. So, I mean, everything from their domain controllers all the way down is every single machine on the campus, essentially, was just a hacker playground, just absolutely loaded with illicitly installed FTP servers and web servers and, you freaking name it. Porn, wares, like everything was coming out of that place. When absolutely nobody internal to the organization was doing anything whatsoever on the network, their T1 was still fully 100% saturated. And this was back when a T1 was like a lot of bandwidth.
Yeah, I think the power plant also had a T1. But I remember also when I got to college, finding out that my college, which isn't that big, had an entire /16. And I'm like, well, could you carve off a couple of /24 for me? I could make a lot of money off of those.
So what's the logical conclusion of this? Is the price just going to go up and up and up as they get more and more scarce?
Yeah.
As they have for the last 30 years.
Yep, that's going to continue. Honestly, the prices aren't increasing enough to motivate much of anybody to do much of anything other than pay their hosting provider what they have to pay to get IP addresses. The actual scarcity is what truly drives adoption of IPv6. It is slowly happening, and it will continue to slowly happen. But in order for pricing to really substantially affect that, Amazon would have to be charging 10 times what they are. And everybody else would have to go along with it with them.
Yeah, because even at 10 times this cost, if it's only a couple of dollars a month, that's not going to push most people into not using it.
Yeah, where you saw some of the biggest impacts is most cell phone providers these days are using IPv6 for your phone. When you connect to the cellular network for your phone, you get an IPv6 and that's what you get and you enjoy that. And that works now. That did not work very well before cell phone providers started doing that and using carrier grade NAT and everything else. But it was the actual scarcity that drove it, not costs. It was when, you had outfits like AT&T looking at the cold hard facts and being like, we cannot reliably source enough IP addresses to keep signing people up for cellular service. That drives some real innovation in making sure that IPv6, carrier grade NAT, you name it, will actually work and you actually can relieve some pressure on the IPv4 space. But until that level of not just it costs a little bit more money, but I literally cannot do this reliably at the scale that I need to, until that happens, IPv4 is going to continue being the king, unfortunately.
Yeah, and you saw adoption of IPv6 at places like Facebook because suddenly it meant they could identify the same phone contiguously, whereas when it was going through the carrier-grade NAT, it would get munged together with a bunch of other traffic. And so you saw Facebook make a very big push suddenly to have really good IPv6 support because they wanted every phone to talk directly to them, not go through the carrier-grade NAT first. And then when Comcast finally rolled out V6, you saw firms like Netflix are like, yeah, half our traffic is V6 now.
Yeah. I kind of wonder if that's the same reasoning that Google went on. Like they're all of a sudden just enormous push to like, if you don't have proper V6, everything set up on your mail servers will bounce everything. Because that's been several years ago, but when it happened like overnight. And the way that I found out about it was all of a sudden I could not deliver mail to anything Google anymore until I immediately fixed it. I was not very happy about that.
So when do you think we're going to get to the point where we just literally run out?
Well, I mean, we're never going to literally run out entirely. It's just a question of increasing scarcity. And I'd give it about 10, maybe 20 years.
Technically, we ran out already.
Yeah.
All the addresses are allocated. It's just somebody's always willing to pay somebody enough money to take their addresses.
We're scavenging at this point.
Yeah. And there's a project underway from, I forget which group, a group of internet graybeards, to try to reclaim some of the reserved IP addresses. So, for example, the experimental range, like 240/10 or something like that, anything that starts with 240 to 247, that range was been reserved forever just as experimental. And other than the fact that it's in lots of routers and switches, like bogon list of any traffic you see from this IP address must be spoofed, other than that, there's no reason we couldn't actually be using those IP addresses. The problem is nobody would want to buy them and use them if they're blocked on half of the internet.
Yeah, that is a big other than.
Yeah, well, we saw the same problem, when Cloudflare wanted 1.1.1.1 to work, they eventually made it work enough or created enough buzz around it that most of the places that were blocking it stopped. And so this group is creating an overlay VPN on the internet, basically, to start testing using those IP addresses. Then they went a little too far and decided, well, the 127 loopback thing only really needs to be the first /24, right? But, that would be, an entire /9 plus half of a /10 or whatever that we could get back. And that's a lot of IP addresses that somebody could sell.
It's a drop of piss in an ocean, though, because when it comes right down to it, IPv4 only provides, bogons and everything, about 4.3 billion addresses. Not quite 4.3 billion, which is enough for roughly half of the population on the planet to have one. How many internet-capable devices do y'all own?
Yeah.
I definitely own more than my, rated 0.5 personally. I don't know about everybody else. So yes, we are out of IPv4 addresses. It's going to continue getting worse. And honestly, the biggest thing that puts pressure on it and gets us to the point where eventually there will be enough scarcity that there is a true mass migration to mainstream IPv6 adoption. What's really going to drive that is, as the rest of the world continues to come online, there will come a point when even the absolute poorest, most exploited, least advantaged country, still all of their citizens are pretty much on the internet with one or more devices. And as we approach that point, IPv4 just plain won't work. Because again, there's not enough for every individual on the planet to have a single IP address to themselves. That ain't going to scale.
Whereas with IPv6, we got about 6.5 times 10 to the power of 23 addresses per square meter of the Earth's surface.
I'm just a little annoyed that the original IPv4 spec didn't just go for 5 octets instead of 4.
They were going to make it 48 bits, which I think would have been 6 octets. There's a great talk from Kirk Music of the FreeBSD project about the discussions back in the day about the people pushing for 48 bits versus 32. And if they had just done that, how much better all of our lives might have been.
It really would. Because, by the time that you have to do something as painful as the migration to an entirely new address scheme, what IPv6 is, it's understandable that we go I'm going to be the one this time, that we take the ZFS approach and make it like ridiculously large to the point that, we can have the entire galaxy on it, right? But the thing is, when we were initially designing IPv4, we could have put that off for like a century if we just added an octet or two. And that would have been a very, very well-bought century, in my opinion. Now, it just absolutely doesn't make sense. Like, if we've got to replace it, we should absolutely replace it with the forever thing. But, if I could go back in time and just, like, shake some people by the neck, they're like, 4 billion's plenty. Yeah, we're not going to run out of that. What's everybody on the planet going to want one? Yes, everybody on the planet will want 10, 100, not just one. And it will be everybody.
Okay, this episode is sponsored by Kolide. If you work in security or IT and your company has Okta, this message is for you. Have you noticed that for the past few years, the majority of data breaches and hacks you read about have something in common? It's employees. Hackers absolutely love exploiting vulnerable employee devices and credentials, but it doesn't have to be this way. Imagine a world where only secure devices can access your cloud apps. In this world, phished credentials are useless to hackers, and you can manage every OS, even Linux, from a single dashboard. Best of all, you can get employees to fix their own device security issues without creating more work for IT. The good news is, you don't have to imagine this world. You can just start using Kolide. Kolide is a device trust solution for companies with Okta, and it ensures that if a device isn't trusted and secure, it can't log into your cloud apps. So support the show and visit kolide.com/25A to watch a demo and see how it works. That's KOLIDE.com/25A. Google's new security pilot program will ban employee internet access. So this is a trial program within Google, and employees can opt out of it if they want. And it essentially just gives them access to Google's sites like Gmail and I assume YouTube. So that is a good chunk of the internet anyway.
I would just like to point out that now they can opt out of it. Originally, it was not supposed to be opt-outable. But I think Google suddenly realized that, hey, we might be looking at the next crop of Apple employees right now. So they made it an opt-out thing. And I've got to imagine that both kept some people from literally quitting, which I would not at all be surprised if some people were like, I will quit before I will work at Google with no internet access.
I don't understand how you do your job without internet access.
Well, it's internet access on that PC. Maybe you have a second one beside you that does have internet. It's just it doesn't have the sensitive data.
I suppose, yeah.
Which kind of raised for me the question is like, could you just finagle this so that you had a VM that does have the internet on your machine?
Right.
So that your sensitive data is on your host machine and you do your work, but you have a browser or whatever on this other machine that can get out to the internet and you can do what you need to do, research what you need to research in order to work on what you're working on.
That is, on the face of it, obviously the more sensible approach. The problem with it is it doesn't scale. Google employs a huge number of people, and anytime you have a huge number of humans, you cannot expect them reliably to do things like do the sensitive thing in the sensitive compartment and the dangerous thing in the non-sensitive compartment. They will not do it. They will just do everything in one thing.
The better engineers there are going to find a way to connect from the internet from the outside, not just the VM and so on. Exactly that problem, yeah.
And the ones who aren't better engineers will just stop doing anything more than they have to. And the one that can't get it anywhere else, they will find ways to do their work in the other one. Or it's just, it's like I have a client that they had public printers set up in their hallways. And their former IT person had set all these printers up with like a wireless direct printing, so like it's not joined to the organizational Wi-Fi. You have to change your device over to the Wi-Fi network being put out by the printer in ad hoc mode in order to print, and then switch back to the organizational Wi-Fi to be able to do anything else but print to that one single printer. And amazingly, nobody used them. So I went into that organization and I put all the printers on the organizational network, and it's amazing. Now those printers go through a ream of paper a week. How about that?
Yeah, and it says, like Jim was mentioning, the report said Google's new pilot program will disable internet access on select desktops with the exceptions of internal web-based tools and Google-owned websites like Google Drive and Gmail. This was originally mandatory for the 2,500 employees who were selected for the pilot program, but after, quote, receiving feedback, quote, they're going to assume that some very enthusiastic feedback, Google is letting employees opt out of this program. The company also wants some employees to work without root access, which is common sense for a lot of computer roles, but not really for developers who are used to being able to install new programs and tools.
Yeah, what do you think about the root access thing? Surely, if you're just in marketing or something, or sales, do you really need root access to your machine?
This comes back to Alan's whole thing with the VMs, and this was something I was thinking when I first read this article. This is where the VM approach really would work well, because you do not need to have root on the bare metal. You can be given a VM you have root over to do your root needing development tasks, but everything else can be out there where you are not admin, where you are just a normal unprivileged person. You can also fairly easily then say, okay, well, the VM where you have root is not, you can't have like a browser in that or whatever. And you can set up some pretty stringent guards there that will actually work for that. That would be something that is pretty reasonable and simple to accomplish. I would also like to point out that enthusiastic feedback is quite a euphemism for somebody leaving a steamer in the boss's coffee cup, which I'm pretty sure is what happens when you tell 2,500 people you can no longer access the internet.
At work, yeah. All the clever ideas I can come up with of how to implement something to not need to restrict people from the internet entirely suffer from the problem Jim mentioned of people will just start doing their work in the unsafe side of the computer.
Yeah, whether that's another machine or a VM or whatever.
Yeah, because I remember there was a company that was making laptops that were actually going to be like a hardware virtualized, and you would have two installs of your OS. One that, when it was active, it would have like a border around your screen or whatever, and that was the secure one, and that's the one that would be on the company VPN. It could access the sensitive data, but couldn't do everything. And then there was a button or a key combination. You'd switch over to the insecure operating system, and there you had access to the internet and everything. But if you're trying to do work and you need the internet, you're going to start doing more and more of your work in the internet accessible side until you're leaving the sensitive data laying around on the insecure machine, and then you've defeated the purpose of having the other machine entirely.
And the reason that I say that idea of separation via VMs works a lot better for dev work than for most things is because that gives you the opportunity to say, okay, so, my dev environment VMs are going to be a very, very close environment to my production environment. And ideally, we deploy those with a whole bunch of stuff like pre-done for the dev, where by far the easiest thing to do is to dev in this nice, everything set up for you, ready to rock dev environment you were given that lives in a VM, and that VM is not allowed to touch the internet directly. It has all the strictures on it that you want. Now you've created a situation where the easiest thing for your employee to do is to use the computer the way that you wanted them to in the first place. They do the dev work inside the VM where the environment is correct and everything's already set up for them, and it would be a major pain in the butt to try to replicate it outside. If you've never shepherded a bunch of devs through setting up an actual work environment on like a brand new clean laptop, that is a struggle every time. So if you can hand them something just ready to use, believe me, they'll freaking use it, because they do not want to go through like setting up libraries and environment variables and, all the other things that might be necessary to get the correct environment. That also gives you the opportunity to let your VMs have their Windows machines or their Mac machines or their whatever, but if they're deploying for prod to a Linux or a FreeBSD environment, give them a VM with that operating system, which eliminates any number of pain points. I can't tell you how many nasty issues I've had to deal with that cropped up purely because a dev is, they're writing code that's intended to run in a Linux production environment, but, they're writing it on a Mac with like a bunch of weird crap they installed using half homebrew and half downloaded whatever from the internet, all wrong versions, you name it, versus here's a VM, it's ready to go, it's got all the right libraries installed, all the right tooling, everything is set up to mimic production as closely as humanly possible. All you got to do is start hacking. That's the way to go.
Yeah. Because I know some phone OSs are now looking at trying to have, a secure section and separate, or be able to have, your work stuff on like one side of the phone and separate it from your not work life on your phone. Although the answer there is usually two phones, but then you get the problem, well, I only have this phone. So suddenly one phone's going to have the mix of the things on it.
This is perhaps even easier in a Windows environment, not meaning Windows production environment, but, like Windows laptops being handed out, because you can have your devs use WSL and you can control WSL's direct access to and from the internet, yada, 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 via policies deployed by Active Directory. Will it be some initial setup for you to, get that going? Sure. But once you've done it, it'll be pretty easy, not only for the devs to just use their ready to rock development environment in WSL on their laptops, but easy, for the admins that are running the organization to automatically provision new dev laptops that have all these things just set up and ready to go from the get-go.
What makes it so tricky is that it's not a technical problem. As with all security things, it's how do we get the meat puppets to do the right thing? And if we make it at all too frictionful for them anyway, they will just find a way around it. And that's where all the problems come from.
Ever seen cattle shoot, Alan?
Yeah.
That's how.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Jorge says, could you please explain the recent trend of loading device firmware from within the OS, specifically for Wi-Fi cards? I've noticed that most of the firmwares in lib/firmware are meant to be uploaded to the device by the driver during OS boot time. Unlike Win modems in the past, where operations were offloaded to the driver/OS, these firmwares still run on the device. Could you clarify this concept for me?
So the first thing is it's cheaper to make the Wi-Fi card without some flash chip to hold the ROM. And so they just put it in the OS and load it at runtime each time. Other part of it is it often helps to have the firmware match the driver. So when you have different versions and so on, to have them cooperate. And so having the firmware loaded by the driver means that you will get firmware that can communicate properly with that specific driver. But mostly it's to save a few cents by not including an EEPROM for the Wi-Fi card or whatever the device is.
And we don't do it the way that Win modems did in the past, with functions being offloaded into the computer rather than onto the card because it's a latency issue. If you got to go back and forth to system RAM to fetch your instructions, then you've got a pretty serious bottleneck that you've introduced into how quickly that device can process information.
The really interesting part of this trend has been seeing more and more of the work move from the driver itself into that firmware that's loaded by that binary blob that you don't get to see inside of. And seeing that, especially in Wi-Fi, but also starting to see it in other devices where more and more of that functionality, especially with GPUs even, is going from the driver, which whether or not it's open source even, into the hardware itself. So the functionality moves from the driver into the firmware that loads on the hardware itself. So the driver becomes easier to maintain, especially if you have to do that across a wider range of operating systems, or especially if you're, Intel or somebody in writing drivers for Linux, and you need that functionality to exist across a very wide variety of Linux kernel versions. You don't, depending on functionality having to be backported from newer kernels when you want to use newer APIs and so on, if you just have all that happen in the firmware blob that runs on the device itself, and the driver becomes a thin layer of just translating resources and stuff it needs from the operating system to the device.
That also makes it a lot easier to automatically update those devices. And you may have noticed that most humans are not real conscientious about, oh, there's a new firmware available for my, mouse. Let me make sure I go and download that and manually install that and upload it to the device and everything else. Whereas if you've just got a driver that's automatically looking for new versions of firmware and uploading them as necessary at boot time, well, then you're always on the freshest, whatever at boot time. Now, that does mean that, any compute archaeologists in a few decades are going to be in a real world of hurt if they're trying to unearth old hardware that doesn't actually have the firmware in it because it's intended to be loaded by an OS that you no longer have the access to, from repos that are no longer around because that OS is long gone. Like, that's going to be an issue, but to be fair, it's really only going to be an issue for, a very niche set of hardware archaeologists. So probably not the biggest problem.
Well, as long as those firmware images are included on the install media and archive.org keeps ye olde versions of random distros, then hopefully they'll be able to still make that old hardware work.
I would like to point out that at this point, install media is rapidly becoming as obsolete as like a floppy disk picture as a save icon.
Yes. I just mean the ISO file that we all pretend that we're going to burn to physical media to install from.
Well, the USB stick is physical media, isn't it?
Yes, but it absolutely will not survive for long enough for future archaeologists to retrieve data off of it.
Yeah,
true.
So, immaterial.
But the image file that you downloaded from the distribution's website, hopefully, is what's archived at archive.org. Don't waste physical space on CDs and USB sticks. I just mean the image file that hopefully you'll be able to use in the future still to get all that old hardware working.
Yes, the Linux ISOs that we're all downloading and saving.
Yeah.
It's what mine is full of.
It's what everybody's is full of.
What's interesting is that the add-on devices we think of like Wi-Fi and GPUs are not the only thing that work this way. This is what CPU microcode does. And it's even more interesting there because while you can get newer CPU microcode and have that installed in your operating system and it will apply it to the CPU at boot, that's actually what the BIOS is doing when you power the computer on. And that's how installing a newer BIOS will basically include that newer microcode and load it at boot every time. And then if your BIOS is older, at boot, you're going to load some medium old microcode. And then when the OS starts, it'll load even newer microcode and overwrite the microcode we just loaded with slightly better microcode. And we've been patching our CPUs at boot this way for decades.
And probably the last thing we really need to say about this is a lot of the reason for all of this Byzantine stuff is it allows hardware manufacturers to get their devices out the door with less fear about whether their QA caught everything. Because, if we ship it out packed chock full of bugs, well, whatever. We can just have people's operating systems and or motherboard BIOS upload non-buggy code on every single boot from now until the end of time, and that'll be sufficient to keep the customers from getting angry, mostly.
Hopefully.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joerest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Ellen Jude.
We'll see you next week.